Hello students, welcome back. Before we go over to the next question, I would request you to go through the playlist featuring the previous year's solved physics numericals board questions. I have shared the link of the playlist in the description box. I'm sure it will be of great help to you in course of your exam preparation. Now let's see what today's question is. It's a question from light chapter and it reads like many optical instruments consist of a number of lenses. They are combined to increase the magnification and sharpness of the image. The net power P of the lenses placed in contact is given by the algebraic sum of the powers of the individual lenses P1, P2, P3 as P is equal to P1 plus P2 plus P3 and so on. This is also termed as simple additive property of the power of lens, widely used to design lens systems of cameras, microscopes and telescopes. These lens systems have a combination of convex lenses and also concave lenses. So here we are talking about the combination of lenses. So how are various lenses combined to give the desired effect? So now the question that follows are, what is the nature, whether it's convergent or divergent, if the combination of a convex lens of power plus 4D and a concave lens of minus 2D are combined together? Okay. The second question is, calculate the focal length of the lens whose power is minus 2.5D. Okay. Then draw a ray diagram to show the nature and position of an image formed by a convex lens of power plus 0.1D when the object is placed at a distance of 20 cm from its optical center. So we have to find out the nature of the lens system when they are combined together. We have to calculate the focal length of the lens whose power is given as minus 2.5D, and we have to draw the ray diagram to show the position and image formation of a convex lens whose power is 0.1 diopter and when the object is situated at a distance of 20 cm from its optical center. So let's start. In the first question, we are asked to find out the nature of the combination of lenses. So which are the two lenses? Let's write down first. So one lens is a convex lens of power plus 4D. It's a convex lens. And we have a concave lens whose power is minus 2D. Now here you see it's written here the combination, the net power of the lenses which are combined together is given by the algebraic sum. It's very important. Algebraic sum of the power of the individual lenses over here. So we have to add them algebraically. So the net power will be plus 4 plus of, because here it's given that P is P1 plus P2 plus P3. So plus 4 plus minus 2, which is plus 4 minus 2, which is plus 2D. So the net power will be plus 2D and it will be a converging lens. Why? Because the power we are getting in positive. So positive power means it's a convex lens. So it's a convex lens or a converging lens. So the answer is convergent. Then bit B, calculate the focal length of a lens of power minus 2.5D. So power is given here as minus 2.5D. So it's a concave lens because its power is negative. Now power we know is the reciprocal of focal length. So focal length will be 1 by P. That is 1 by minus 2.5, which is minus 10 by 25, which will be minus of 0.4 meter. So focal length is minus 0.4 meter. But always remember children that whenever you need to express focal length, it should be in centimeter. And whenever you have to express the power, convert the focal length into meter and then express the power. So F will be minus 40 centimeter. Okay, so the focal length of this lens is minus 40 centimeter and it's a concave lens. The third bit is given as draw a ray diagram to show the nature and position of an image formed by a convex lens of power 0.1D when an object is placed at a distance of 20 cm from its optical center. Okay, so we have the convex lens whose power is given as plus 0.1 d, which means that if you find out its focal length, which will be its reciprocal of the power, so it will be 1 by 0.1 d, which will be equal to 10 meter. So now we have the focal length of this lens is f is 10 meter, which is 1000 centimeter, and our object distance is given as 20 centimeter. The object is at 20 centimeter, so the u will be minus 20 centimeter. So let's draw the ray diagram. So this is a convex lens. This is the optical center. This is f1, f2, this is 2f1, and this is 2f2. Now if the focal length is 1000 centimeters, so let's say this be 1000 centimeter. Object is situated at 20 centimeters, so our object will be situated here. So if we draw the ray diagram for this, one ray will go parallel to the principal axis. After refraction, it will pass through f2. Okay, then another ray will pass through the optical center undeviated. Now in order to get the image, we have to trace these two rays backwards. So we see that these two rays meet over here. So here will be the point. If this is A, B, this will be A dash, B dash. So this will be the position where the image will be formed, and the image will be a virtual image. It will be upright, it will be magnified, it will be formed on same side of the lens where the object is. So the nature, it's a virtual image. It's upright or erect, it's magnified, and it is formed on the same side of the lens as is the object. Okay, so the nature and position of the image we found out, and if we want to find out the image distance, we'll apply the lens formula and find out. But here it's asked to draw the ray diagram to show the nature and position, so we are drawing only the ray diagram for it. I hope you have understood this question. If my videos are helpful to you, please like the video, share it with your friends, and subscribe to the channel. Thanks for watching. Bye.